In this video, we'll see how to design a REST API and implement it using Spring Boot. Let's first review a few things. First, JSON. Most of the REST API produce data in JSON format. It's basically how you would write an object literal in JavaScript. You'll specify a number of property name and their values inside a pair of braces, and the property value can be an object itself. In JavaScript, strings can be single-quoted or double-quoted. For example, Honda can be single-quoted or double-quoted. And property names can either be strings or identifiers like variable names. For example, the property make can have a string name or it can have an identifier name. Because JSON is intended as a data exchange format, it limits the JavaScript object syntax a little bit to only allow double-quoted strings and the string property names. So this way, it makes it easier for other languages to parse JSON objects because they don't need to handle the other cases. And this is what a HTTP request looks like. The first line is called the request line, which has three parts: request method, request URI, and the protocol. After that, there are a number of headers, and after that, there's an optional request body. In CS3220, when we write Java web applications, we mainly get user input from request parameters. But web APIs also frequently use other parts of a HTTP request, especially the things I highlighted here. In particular, request method is often used for representing the operations in a REST API. They are literally the method names in an API. For example, in this case, it's like calling a method called post. Request URI is used for representing resources. Think of a resource like an object or a collection of objects. For example, here, this URI represents a collection of products. When a client sends an object to a REST API, the object is sent in the request body, like here, and the content type header tells the server the format of the object in the request body, and in this case, it's JSON. The accept header tells the server what format the client prefers. This is useful if the server can produce more than one format. For example, depending on the accept header, the server can send back data, in this case in XML format, because the client says it prefers XML format. This is what a HTTP response looks like. The first line is called status line, which has a protocol and a status code. After that, there are a number of headers again, and after that, optional response body. In REST APIs, status codes are often used to indicate the completion status of an operation. The return value of the call will be in the response body, like this one. And again, the content header has a format of the data in the response body. Here are the status codes that you'll see quite often. If everything is fine, you'll usually return 200. Sometimes you'll return 201 or 205, depending on the operation. For example, if it's a create operation and is successful, you would want to return 201 created. If a method returns void, you can return 204, indicating that there's no content in the response body. And then for different problems, you would use different error codes. For example, if a request doesn't have the required fields, the appropriate status code is 400 bad request. If a user should log in but hasn't, the code should be 401. If the user has logged in but doesn't have the access privilege needed, the code is 403. If a requested resource doesn't exist, of course it's 404. And if it's a server error, like a SQL exception, you can send back a status code 500. Okay, now that we are all up to speed about HTTP basics, let's see how we can design and implement a REST API. We'll do an example of managing employees because, again, we can recycle the code from the Spring and Hibernate example. We'll do a few operations and use them to discuss the common issues in REST API design and implementation. Let's start by designing the API endpoints. As we said in the web service video, this is what a quote-unquote method in a REST API looks like. You call the method by sending a request to a URL, and you parse the response to get the return value. In web API terminology, this is often called an endpoint of API, similar to, say, a method in an interface. Designing a REST API like that is really not too different from coming up with a method that's called, for example, getUser, which takes an integer parameter and returns a user object. In both cases, you'll need to specify an action and the resource the action applies to, a way to supply parameters, and a way to get the result. The easiest part of REST API design is probably deciding the format to represent objects. There are really only two options, XML and JSON. If you can choose either or both. If you choose both, you can let clients to select which format they prefer using the accept header. If you are unsure, just choose JSON because it's a more efficient format, and there's a good chance that the client is written in JavaScript. Technically, you can design your endpoints any way you want, but if you want to call your API a REST API, there are some design conventions you should follow. Take this one as an example. Suppose we want to design a REST API endpoint for getting an employee by ID. The first design would be considered a good design, while the second one would be considered a bad design. Although functionally the second design here is really no different from the first one. In fact, when we write web applications, we often use URL patterns like this. But remember, we are designing web APIs, not web applications. REST APIs in particular follow certain conventions to make them quote-unquote REST. Here are the four important conventions. First, use URL to represent resource. Then, use request method to represent action. Third, use request headers for content type and content negotiation. And fourth, use response status code for result status. We have already talked about using content type header and accept header. And we already talked about status codes. Let's explain a little bit more on using URL to represent resource and using request method to represent action. Suppose we have an employee class like this, with ID and name, and supervisors and subordinates are also employees. In a REST API design, we could use /employees to represent all the employee objects. We can use employees/ID to represent an employee with a certain ID. Note that it's also customary to use URL path segments to represent the structure of objects. For example, the name of the employee with the given ID is this plus name, and the supervisor of that employee is this plus supervisor. And similarly, you have the subordinates of the employee with given ID. And if you want to pick a specific subordinate of this employee, you can add ID to this URL. So we can use URLs to represent objects, but it doesn't say what action we want to perform on the objects. This is where we use request methods. Remember, there are quite a few request methods, like get, head, post, put, delete, connect, options, trace, match, and so on. Although we mainly use get and post when we write web applications, when we implement web APIs, we use a lot more different request methods. And some of these request methods actually map nicely to the so-called CRUD operations: create, retrieve, update, and delete. Specifically, post is usually mapped to create, get mapped to retrieve, put or patch maps to update, and delete, of course, for delete. The difference between put and patch when used for update operation is that if you update by providing a full object, use the put method. You can think of it as putting the given object as a URL. Sometimes an object is large and you may only want to update some properties. It will be inefficient to have to send and process the whole object. In this case, you can send only the properties you want to update, and the appropriate request method to use is patch. You can think of it as using the provided data to patch the object at the URL. Although some REST API people would like you to believe that all operations can be expressed in request methods, the truth is that some cannot. A good example is the search operation. A search operation can be quite complex. You may want to search by field, for example. You may want to search only the first name of the employees. And then search may involve logical operators. For example, you may want to say, search the employees whose first name is John, but last name is not Doe. Now you can read HTTP specifications all day long and you won't find a request method that matches search exactly. And the reason is simple. When HTTP was designed, the designers didn't know that the request methods would later be used as web API operations. So what do we do in this case? Well, the first thing to remember is that all this stuff is really just conventions, not some hard rules. It's good to follow conventions when it makes sense, but if the convention doesn't cover it, like in the search case, you are free to come up with your own design as long as it's reasonable. For example, for a search endpoint, I would just use get method with a query object in the request body. So with that, let's build our REST API. We'll use Spring Boot, which has become the preferred way of using Spring. The first thing you'll notice when you use Spring Boot is that it greatly simplifies the configuration of Spring. And then you'll see that you no longer need to deploy your web application because Spring Boot embeds a Tomcat server in the application itself. So you can build and run a Spring web application as a regular Java application. No deployment necessary. Spring Boot also comes with additional features such as monitoring and metrics, making it very good for production use. So without further ado, let's create our Spring Boot application. We'll go to this page, which has some information about starting a Spring Boot project. So there are various ways to create a Spring Boot project. Spring Boot has plugins for Eclipse. It has extensions for Visual Studio Code and some other IDEs. So you could install those extensions and start a Spring Boot project right inside the IDE. I personally like to keep my IDEs simple and plain. And in my case, I'm going to go to this web page, which lets you to generate a Spring Boot project by selecting some options. So we are going to start with Maven project using Java, of course, the latest Spring Boot version, and then we'll give it a group ID. Let's make up something. We'll call it CS5220 examples. And the artifact ID, let's call it SB-REST, Spring Boot REST API, and REST API using Spring Boot. And let's shorten the package name a little bit. Let's just call it SB-REST. And notice here that you want to select jar packaging because, as I said, it's going to be a regular Java application rather than a Java web application because it comes with its own embedded Tomcat server. And for JDK version, I'm going to use 8, a little bit conservative. And then let's add our dependencies. So we want several dependencies. One of the things Spring Boot does is it does not ask you to select individual library dependencies, which could be quite a lot. Instead, it groups dependencies into the so-called meta dependencies. So you can kind of just select certain dependency group and it automatically adds the individual library dependencies. So we want these 4 groups: Spring Web, Spring Boot DevTools, and Spring, where is the Spring Data JPA, and then the database driver, which is, where is the database driver? MySQL driver. So this is, by the way, Microsoft SQL Server, so they're right next to each other. Make sure you choose the right one, the MySQL one, not the Microsoft SQL Server one, of course, unless you use SQL Server. Okay, so once we have these options selected and the dependency selected, we can just click Generate. It will create a Spring Boot project and download it as a zip file. So let me extract the zip file and then import it into Eclipse, and then we'll be in business. So let's import, and this is the project. So give it a little time to do the importing, downloading dependencies, configuring the project in Eclipse, and all those things. Still downloading. Okay, so now the project is ready, and let's see what we have here. If you look at the project, other than the POM file and a few things related to Maven and stuff, the only two things relevant to the project itself are the main method or main class and the application.properties class configuration file. In Spring Boot, instead of those tons of configuration files in Spring Web MVC, there's only one configuration file you'll need to worry about. That's application.properties and their source main resources. And we need to give it a few properties, and we need these 4 properties that points Spring Boot to our database. So I'm going to copy over the database URL from my previous example. So my database is here. By the way, now would be a good time to check if my database is indeed still there. Okay, so I have a bunch of employees here. Let me get rid of some of them so that later on we have a cleaner table to work with. Okay, so I do have my database there, and username and password. And the driver name is a CG driver, which is the MySQL 8 driver name. And in addition to these 4 properties, we need a couple of more. So this one will tell Spring Boot to use MySQL 8 dialect for JPA/Hibernate. Otherwise, by default, it will use MySQL 5. And we would also want this one. So this one will automatically create the database tables if the tables are not created. So this is quite convenient. You no longer need to do schema export and then run the script yourself. This will automatically create the tables for you. Okay, so now we have this ready, and we can try run it. There are a few ways to run a Spring Boot application. The easiest way, if you use Eclipse, is to just run it as Java application. Just select the main class and do run as Java application. Again, it's a Java application, not a server web application, so do not do run on server. To run as Java application. Oh, so it doesn't like my database URL. I think that's because it actually prefers this instead of that. And Okay, so it reloads, and this time it seems to be okay. And so now the Spring Boot application is running. As I said, it starts a embedded Tomcat server, and if we go to HTTP localhost 8080, we'll see something called a white label error page, meaning that it's running, but we haven't done anything yet. So that's good. Let's stop it and actually put some code in it. So the first endpoint we want to implement is list employees, and because Spring Boot is still Spring, we can actually reuse all of our model and DAO code and most of the controller part too. So let me do that, and I will, what do we do? So this is the model class. Let me just copy over everything from here. So here, so I want everything inside model and the web, and let's put it here, and then let's refresh. Okay, so we have the model class here, and let's just change it to SBRest, and we also have the DAO. Let's change it to SBRest model DAO. SBRest and SBRest, and okay, so let's get rid of the index controller, and let's work on the employee controller. So this is the web MVC controller we did last time, and last time we have several controllers, each has its view and so on. So since we are doing a web API now, there's no view. So first of all, let me get rid of these methods, and we can focus on the list one. And here, there's no view anymore. So it doesn't return a view anymore. Instead, it will simply return a list of employees. So it will do something like this. And here, we'll have to change it to list of employee. And then we need to make one more change, because normally a controller method will return a view name, but now we are not returning a view name, we are returning data, and this data needs to be put inside the response body. So we'll say response body here, telling Spring that the return value is not view name anymore. It should be an object stored in response body. Okay, so now we can run this thing again. And if we go to /employees, we get our first REST API endpoint. Nice and simple. So first of all, as we can see, the most important thing about Spring Boot is that it's still Spring. So we are still dealing with beans, annotations, varying, and all that. This is why we can just copy over all the code from the Spring Web MVC example, and pretty much everything is still the same, except of course controller no longer has views, but it's still MVC architecture with all the DAO classes, and it's basically MVC minus the V. The difference comparing to Spring Web MVC is, of course, the configuration is greatly simplified. Now there's only one configuration file we need to deal with instead of at least 4, and the configuration also is quite a bit simpler because Spring Boot's convention over configuration, it uses lots of defaults that you don't have to specify manually. The second thing about this is where is the code? Is the conversion of Java objects into JSON objects. And this is known as serialization, and the other way around is known as deserialization. And also sometimes they are called marshalling and unmarshalling. As we can see, our controller method returns a list of employee objects, and it's automatically serialized into a JSON array. Spring Boot uses a library called JSON that does serialization and deserialization. By default, Spring Boot only configures support for JSON, but if you want, you could also configure it to do XML or do both. And one more thing about this is when we do Web MVC controllers, we typically annotate the controller with controller and then return values of controller methods or view names. But for APIs, there's a convenient annotation called REST controller. REST controller is basically controller plus response body, meaning that we no longer need to specify response body for each method. And there's one more thing, because in web APIs, request methods are important. Usually when we specify request mapping, we will need to specify also the method to be, for example, method get. And in Spring, there's another convenience annotation for this. We can combine both request mapping and method attribute into get mapping. So this one will only handle get requests that goes to this URL. So if you look at this code, it's pretty simple, but if we take a closer at this, there is an issue. So to make it more clear, let's go to a JSON formatter and then format this into something more readable. So you look at the returned JSON array. It contains 3 objects. That's good because we have 3 employees, Sue, Joe, and Tom. However, you look at them and you'll notice that for Sue it's simple, just ID name supervisor. However, for Joe, it also includes the supervisor object Sue, and for Tom, it includes Tom's supervisor Joe and Joe's supervisor Sue. So, in other words, for each employee, not only it includes the employee, but it also includes the supervisor if the employee has one, and the supervisor, and so on. So this, of course, is highly inefficient because it takes extra queries to the database to load those supervisors. And for a list of employees, we really don't need all those supervisors. Usually, at most, we only need the immediate supervisor of each employee for an employee list. So this is actually a fairly fundamental problem of sending model objects to clients. Although when we talk about model view controller architecture, the model part usually refers to the data models that store data. There are actually other types of models. The observation here is that the data models are designed for keeping data, and they may not be the best for other purposes. For example, in our case, the data model employee has a supervisor, 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 and so on, but the client code may not need that. Another example is a data model class for user would include a field called password or hash that contains the user's password. But that field should never be sent to a client. Because of this, people came up with a design pattern called data transfer object, or DTO. It's basically an object that carries data from one part of a system to another, and it's usually used in Web API as the object returned by the API. So let's create our DTO and see how it looks like. We'll create it under the model package, and I'm going to call it employee DTO. And inside employee DTO, I want, of course, the ID of the employee. I want the name of the employee. And we also want the immediate supervisor information. So we'll have two more fields. We'll have the supervisor ID and also the supervisor name. And we'll have a default constructor. And then I also want to create a constructor that takes an employee object and creates a DTO. So if we have an employee object, then the ID would be the ID, name would be the name, and the supervisor ID, well, we have to check if the supervisor is null. So if supervisor is not null, we'll have supervisor ID is supervisor ID, and then we'll have supervisor name is supervisor name. And then, of course, we want the getters and setters. So let's have the getters and setters. And now we have our DTO. So once we have our DTO, there's an error somewhere. Oh. So once we have our DTO, we can change our controller to use that. Instead of returning a list of employees, we're going to return a list of employee DTO. And well, there's a bit more work to do. So employees is this list, and then we need to create another list, which is the DTO list. So we'll say DTOs. DTO, And then we'll have to do employee in employees, and for each employee we create a DTO. Okay, and then finally we can return those DTOs, something like that. And let's see how it looks like. Okay, so I think we don't really need that to see what it looks like. So this is a SU object with ID name, supervisor ID now, supervisor name now, and this is the Joe object, ID name, supervisor ID1, supervisor name SU, and this is the Tom object. So now it looks good. So although the code works, we can see that it's a good thing that we only have like 2 fields in our employee model. Imagine that if an employee has like 30 different fields, then this code becomes quite tedious. Not only that, then later on, when we try to return a collection of certain things, we have to do another round of manual initialization. So this is why there are actually quite a few libraries that do the so-called bin mapping that maps one class to another, because creating DTO is such a common task. When you have time, you should look into the mapstract library, which is a very widely used and very high performance bin mapping library for Java. Now let's look at our second endpoint, getting an employee. So the basic implementation should be pretty straightforward. So we'll do a get mapping, and we'll say employees, we'll say ID, and we'll do employee DTO, and we'll say get, and we'll say pass variable integer ID, and then we can say employee E is employee now get employee ID, and then we can say return new employee DTO, something like this. So let's run this. Wait a bit until it's restarted, and let's try employee 1. We get Sue, looks good. 2, we get Joe, looks good. So this is the basic implementation, and it's pretty straightforward. The problem is, what if employee doesn't exist? Or in other words, we enter an ID that doesn't match any employee. So now we have some issue. Now, we could simply fix this error by checking if the employee object is null, and if it is, we can simply return a null. The problem is returning a null is not really a good solution, because sometimes there's a difference between having a null value and something that doesn't exist at all. For REST API, the proper way is to return a 404 error. But if you look at this method, how can we return a 404 error when the return type of the method is an employee DTO? That takes us to error handling, which is a fairly important subject. There are two general types of errors. Errors that you know will happen, like logging errors, missing required fields, and so on. And you need to inform the client to fix the error. And then there are the unexpected errors, like a database exception. And you need to log those errors for analysis and correction later. For a web application, you can redirect the user to an error page or something, but in a REST API, there's no error page and no redirect. You have to send back a status code and maybe some error message. In Spring, both types of errors are actually handled with exceptions. For the expected error, you can raise a response status exception. This exception will be automatically called by the framework, and the framework will send back a response with the specified status code. For example, if you look at the API, so we want to raise a response status exception, and we can specify a status. We can specify a status plus a reason, and we can specify status plus reason plus a stack trace. So this will do something like this. We'll say if E is null, we will throw a new response status exception, and the status will be HTTP status not found. Where is not found? Yes. And then we can give it a message that says employee not found, something like that. And so if we come back here, we can see that now we have a 4 error, and it's still showing a page because it's detecting the client to be a browser. So Spring Boot is quite smart. When it detects a browser client, it will send back a page, even though technically it's a REST API. But later on, if we use a different client, for example, later on when we use Postman, we'll see that it will send back a JSON object rather than a web page. So a little bit more about exception and exception handling in Spring. Most people who use Java feel there are just too many checked exceptions in Java. Checked exceptions are the exceptions that you either have to try catch or you have to declare in the method header, like those file I/O exceptions, database exceptions, and so on. And that leads to lots of boilerplate exception handling code. Note that Java actually has another type of exception called runtime exceptions. For example, null pointer exception is a runtime exception. You'll never need to try catch null pointer exception because runtime exceptions are not required to be called or declared. Spring uses primarily runtime exceptions, which is good because it saves us from lots of mandatory exception handling code. Even better, Spring also uses aspect-oriented programming to handle exceptions, so we can separate exception handling code into their own exception handler classes. And one way of doing that is use controller advice. If you remember, advice is the additional code we can insert it into existing code using aspect-oriented programming. You can annotate a class using controller advice, and if you want to handle a certain type of exception, then you can create a method with the exception handler annotation. inside the method, you can log the exception and basically do anything you want. And then you can return a response with certain status code using the response entity class. So now that we know how to handle errors, let's move on to implementing the endpoint for adding an employee. So for adding an employee, it's going to use post, of course, and it will be something like this. We'll post to the URL employees. Now, as you see here, oftentimes your controller methods will share common segments of URL. And for these cases, we can simply put the common prefix as a request mapping annotation for the whole class. So I'll put employees here, and this one becomes simply just get mapping, and this one becomes /id, and this one simply becomes post mapping. So we want to add an employee, and once it's added, we send back the employee information, and the new employee will come in as a JSON object inside the request body. So what we'll do is we will say request body, and it should come in as a employee DTO. And once we have that employee DTO, we can say what we do. We'll create a new employee, and we'll say the name of the employee will be the name in the DTO, and we'll have to check if the DTO has a supervisor ID in it. We'll say if DTO get supervisor ID is not null, then we need to get the supervisor. So we'll say supervisor is employee now get employee DTO get supervisor ID, and then we need to set this one to employee. Okay, so once we do that, we do employee now save employee E, and then we will return the newly created employee as a DTO. So we'll say return new employee DTO E, something like that. Well, we'll see. So that will be the code. And now how do we test that? If it's a get method, we can usually just use a browser to test it because it's easy to send get requests using browser. But if it's a post or put or delete, there's no easy way to do it in browser. We'll need to have something that helps us to test REST APIs specifically, and Postman is one of the most popular tools, if not the popular tool. So I'll use Postman. Okay, so in Postman, we can create a new request, and we can specify the request type, and we can also give it a name. How come I cannot give it a name? Okay, we'll deal with the name later. and the URL will be A0A0 employees, and we are going to post to it, and we need to specify a content type header because we are going to send the object to the endpoint, not transfer encoding. Content type, and it's going to be application JSON, and then we need to send the JSON object to be saved by the endpoint, and go to raw and just type a JSON object. So I'm going to, well, first of all, let me check my database. So I have Sue, Joe, and Tom, and let's add another employee, Jim, and Jim will have supervisor. Let's say Jim's supervisor is going to be Sue. Okay, and let's send this. Okay, so we get a response back. It's an employee DTO with ID, the newly created object ID, and the name, and then supervisor ID and Sue. So it looks nice. And if we select the table again, we see Jim is here. So this is good. Now, if we pay attention here, you can see that the status is 200 OK. As we mentioned earlier, oftentimes when you have a create or add operation, and if it's successful, you would typically want to return a 201 status instead of 200 status. The way to do that is quite simple. You can add another annotation here, which is called response status, and inside you can give it a HTTP status, whichever one you want to use. So we'll give it called created, and so if we try again, and this time I'll add Jack, supervisor ID 2, and send, and now we have Jack here, supervisor 2, and also if you look at the response code, now it's response code 201. So this is how we can select the response code that we want. And moving on, let's do update. As we mentioned earlier, there are two ways to implement update. We can update using a full object. We can also update only some properties. Let's do the first one first. So this is going to be a put method, and it's going to put to a certain ID, and again it's going to be, well, this time it's actually not, we are not going to return anything, so it's going to return a void, and the request body will be an employee DTO, and we'll also need the ID, so this one will be pass verbal integer ID, and to update something we'll need to get it first, and then we'll say e.setName is DTO getName, and then we'll need to say, again we'll need to check whether supervisor ID is null, So maybe we want to remove a supervisor, so we do need to check if supervisor ID is null. If it's null, that means we need to set supervisor to be null. And if it's not null, that means we may need to set a new supervisor. So we need to get a new supervisor and set it. So we'll get this one, and this one. Yeah, so if it's not null, then we get the supervisor and this and that. Okay, so that seems reasonable. And then we do save, and then we do return. Okay, so we don't need to return this time. Okay, something like this. Again, we'll find out. So yeah, because we are returning void, and if you are returning void, that means you'll probably want response status and the HTTP status, no content here. Okay, so quickly double check DTO, change name, change supervisor. Okay, let's give it a try. And so let's see, we have Jim ID 106. Let's say we want to change Jim to James. We can do this. We'll create a new request. We'll put post. We'll post to, where do we post? 106. We'll post to 106. And again, it's going to be content type JSON, and the body will be name James, supervisor ID currently is 1. Let's just keep it 1. And the method should be put, not post. Let's try it. So nothing comes back, but we do have the tool for no content, and let's check. So it's indeed changed to James. So now we can do update. So as we mentioned earlier, the problem of doing a full object update is that it takes more bandwidth and more processing, and also it requires a more recent get. What that means is there could be other users also working on the same data, and another user may change part of this object. And if you put the whole object back, you may overwrite some changes made by another user unintentionally. So you would only want to do that when you have a very recent copy of the object. So the alternative, of course, is to do a partial update. And there are actually 2 ways to implement a partial update. One is we can update individual property. For example, we can create an endpoint that using actually the put method and basically saying put a new name to the name of employee number 1, or put a new supervisor to the supervisor of employee number 1. The good thing about this is implementation-wise, it's pretty straightforward. You only deal with one property, you know exactly what property it is. On the other hand, this requires you to create one endpoint for each property. If you have many properties, that of course is kind of a pain to do. So another way to do it is to use a patch request, and Spring actually allows you to map incoming JSON into a map object in Java. The key of the map is going to be a string, and the value is going to be an object, which means it can be anything. And then you can just go through this map and then update properties as necessary. So let's quickly see how this thing looks like. We will, so this part is the same. Actually, let's grab all this. So this one is going to be a patch method, and it will still return no content, and the path variable is still going to be ID, and the request body, on the other hand, is not going to be an employee DTO. It's not going to be a full employee object. It's going to be a map of strings and objects, and let's just call it a patch. The first thing we do is, of course, we still need to get this. And then what we do is we go through this map and then check every property. And if we find the property, and then we'll change that property. So it's going to be something like this. We're going to use a for loop. So we'll say for each key in patch dot key set, okay, and we'll do a switch statement, and we'll say if the key is name, that means the user has sent us a new name, and then we'll need to update accordingly. So we'll say the employee will get a new name, which is the patch get key, and then we break. We have to cast it to a string because it's an object inside the map. So we have to cast this to a string. Okay, so now it's good. And then we will check if it's supervisor ID. And if it is supervisor ID, once again, we will need to check whether it's null or not null. So that's kind of annoying. But in any case, we'll say enter ID. Well, we'll say if patch get key is null, that means we just need to say e.set supervisor is null. And if it's not, that means we will do this again. And this time is patch get key cast to integer, something like that. And then we break, and then we default. Okay, so yeah, looks kind of like this. And let's give it a try. And this time we'll try James again, and this time we'll change the name to, let's say, Jimmy or something. And we are going to do a patch, and same guy, content type and body, and this one we can just give it a name, and we'll say let's change name to Jimmy and send. So 204, no exception, good. And doesn't change, and oh, that's because I forgot to do save employee. Let's do that. And let's try again. Okay, so now it changes to Jimmy. So this is how we can implement a partial update. The key here is that Spring allows you to map pretty much any JSON object into a map with string keys and object values. And last but not least, let's talk about delete. In terms of implementation, delete is pretty straightforward. It's like an update, only simpler. But before you implement it, you would want to think about whether you would want to implement a hard delete or a soft delete. A hard delete means you actually delete the data from database, and that could have some drawbacks. Because, for example, your user may regret that they deleted the data. Maybe it was by mistake. If the user wants to recover the data, there's no easy way to do it. Also, if you want to actually deleting data, there may be unintended consequences. For example, you could have a cascading delete that deletes lots of data, which A, takes a long time, and B, you may unintentionally lose data. Or if you don't do cascading delete, you may end up with so-called orphan data, meaning that the data no longer has its parent, or it no longer has its foreign key, so it becomes just, something that in your database taking up space but cannot be accessed. On the other hand, you can do a so-called soft delete, which you can basically just set a deleted tag on your object without actually deleting it. This one is faster, it's safer, and it's easier to recover. Generally speaking, it's preferable to do soft delete if the situation allows. In certain cases, for example, the law may require that if a user asks you to delete their profile, you have to actually delete it, not just soft delete it. Or in some other cases, the user may run up to their storage quota, so you can not soft delete their files, you have to actually remove their files. In those cases, you have to do a hard delete, but otherwise, a soft delete is the preferred way to do it. Now, to implementing either a hard delete or soft delete is not difficult here. A soft delete would require we add an additional field here, a Boolean field called deleted. That's easy. With that being said, we do need to change our other part of code. For example, we will need to change the list code to remove all the employee objects that are marked as deleted. And if a user tries to get a deleted object, we may send back an error status code of some sort. So there are other additional things you need to do if you want to do a soft delete. So I'm not going to implement that. If you are interested, you can do it fairly easily yourself. So this is the end of this video. See you in the next one.